They look like ordinary buildings, but inside, scientists are handling viruses with no cures and biology that shouldn't exist. These are the labs governments rarely talk about, hidden behind layers of secrecy and global suspicion. What goes on inside could change the course of humanity or unleash something the world is not ready for. Here's 15 of the most high-risk medical research facilities in the world. Starting with number 15, the Wuhan Institute of Virology in China. So of all the high-risk medical labs on the planet, none has sparked more controversy in recent years than the Wuhan Institute of Virology. Once relatively obscure even within the scientific community, the WIV has since become a global flashpoint, suspended at the intersection of geopolitics and biosafety concerns. It's the only BSL-4 lab in mainland China, and its work with deadly coronavirus has made it both a critical research hub and a source of international scrutiny. It was founded in 1956 under the Chinese Academy of Sciences. It was originally a modest research institute that was focused on virology and microbiology, but its trajectory shifted dramatically in the early 2000s following the SARS outbreak. China, seeking to enhance its capability in infectious disease control, heavily invested in expanding the institute's scope. In 2015, with technical assistance from France, the WIV unveiled its BSL-4 lab, a $44 million facility specifically designed to handle the world's most dangerous pathogens, including Ebola, the Nipah virus, and novel coronaviruses. The lab's construction was hailed as a scientific milestone, placing China among the few nations capable of conducting BSL-4 level research. Yet from the start, concerns were raised about training, oversight, and transparency. Internal Chinese documents revealed in later leaks discussed the challenges of maintaining biosafety protocols at such a high level. Then came COVID-19. As the pandemic unfolded in early 2020, attention turned towards the Wuhan Institute of Virology. The lab had been conducting research on bat-borne coronaviruses, particularly in collaboration with foreign researchers, including scientists from the US-based EcoHealth Alliance. One of the viruses studied, RATG13, was found to be genetically close to SARS-CoV-2, the virus responsible for COVID-19. This led to two dominant hypotheses. One, that the virus spilled over naturally from a wild animal reservoir in a wet market, and two, that it may have accidentally leaked from the lab. The second theory, once dismissed as conspiracy, gained traction over time, bolstered by circumstantial evidence, including reports of illness among WIV researchers in late 2019, lack of transparency in Chinese reporting, and the lab's proximity to the outbreak epicenter. The WHO, the World Health Organization, sent an investigative team to Wuhan in 2021, but their access was limited. Their report deemed a lab accident extremely unlikely, but the conclusion was widely criticized as premature and politically influenced. U.S. intelligence agencies released conflicting assessments, with some suggesting a lab origin was plausible, others remaining undecided. But the full truth is a little bit elusive, hidden behind some closed doors, classified reports, and diplomatic stalemates. Yet, despite all the controversy, the WIV continues to function. Its scientists publish papers on viral genomics, pathogen-host interactions, and molecular evolution. It remains one of the most prolific research centers in Asia for emerging infectious diseases. But its reputation, once neutral, now radioactive, casts a long shadow over every finding it releases. Number 14. The Vector Institute in Russia. On the outskirts of Novosibirsk, deep in Siberia, is one of the most secure and controversial facilities in the world, the State Research Center of Virology and Biotechnology, better known as the Vector Institute. Established during the Cold War and still operating under intense scrutiny, Vector is one of only two places on the planet known to store live samples of the eradicated smallpox virus. It's a facility that has earned its place on global high-risk lists, not only for what it holds, but for what it once did in secret. It was founded in 1974 and a central hub of the Soviet Union's massive biological weapons program. This facility originally operated under the guise of vaccine development and public health research. In reality, it was deeply involved in the development of weaponized viruses, smallpox, Marburg, Ebola, and other pathogens capable of mass lethality. After the dissolution of the Soviet Union in 1991, Russia pledged to end its offensive bioweapons program, and the Vector Institute was repurposed as a civilian center. Western intelligence agencies, however, have long questioned whether the remnants of the old weapons program may still linger in the shadows of Vector's ultra-secure laboratories. But what elevates it to high-risk status isn't just its historical connection to biowarfare, it is the level of containment within the facility. Vector operates at Biosafety Level 4, BSL-4, the highest level of biological containment. These labs are equipped to study the world's most dangerous viruses, those for which there are no vaccines, no cures, and extremely high fatality rates. Hazmat suits, airlocks, decontamination chambers, and negative air pressure systems are all standard. The smallest failure in any protocol could spell disaster. And disaster has flirted with Vector more than once. In 2004, a lab worker died after accidentally pricking herself with a needle contaminated with the Ebola virus. The infection was quick and fatal. Then, in 2019, a fire broke out in one of Vector's buildings during routine maintenance. Reports say it happened in a decommissioned section of the facility far from any of the BSL-4 zones, but the mere presence of fire within a site that stores pathogens like smallpox sent shockwaves through the international community. Russia has consistently denied allegations of any covert weapons development, maintaining that Vector is focused on public health. Indeed, during the COVID-19 pandemic, the Institute did play a major role in the development of the Epivac corona vaccine, one of Russia's domestic responses to the SARS-CoV-2 virus. However, Vector's possession of smallpox, a virus eradicated in the wild and considered a potential bioterrorism agent, remains controversial. The WHO has repeatedly discussed the possibility of destroying the last known smallpox stockpiles, housed at Vector and the U.S. Centers for Disease Control and Prevention in Atlanta, but both countries have resisted, citing the need for continued research. Number 13. The National Emerging Infectious Disease Laboratories, Boston, Massachusetts. In the heart of one of America's most intellectual cities, home to Harvard University, MIT, and a galaxy of biotech startups, stands a building so secure, so biologically fortified, that its very existence was once a source of public protest and legal challenge. This is the National Emerging Infectious Diseases Laboratories, or NEDL, located in the south end of Boston, Massachusetts, and operated by Boston University. It's one of only a handful of facilities in the U.S. equipped to handle BSL-4 level pathogens, the kinds of microbes that cause fatal diseases with no known cure. The NEDL was conceived in the early 2000s as part of a national push to expand biodefense research following the 9/11 terrorist attacks and the 2001 anthrax letters. The U.S. government recognized that America lacked the lab capacity needed to study these most dangerous emerging viruses, especially in urban centers. But despite being structurally complete by the end of that decade, NEDL didn't become fully operational until 2012, and its BSL-4 lab didn't get the green light for actual research until 2017. Why the delay? Public opposition. Residents of Boston's South End and nearby Roxbury neighborhoods raised the alarm over placing a high-containment biological lab in a densely populated urban area. Their concerns were clear. What if there was an accident? What if a virus escaped? What if a human error became a city-wide catastrophe? To address the fears, NEDL underwent multiple rounds of environmental impact assessments, risk evaluations, and federal inspections. Independent committees reviewed its safety protocols, and finally, regulators determined that the risk of accidental release was extremely low, and research was permitted to proceed under strict guidelines. Today, NEDL conducts research on Ebola, Marburg, the Nipah virus, and other high-risk agents. It also played a key role in COVID-19 studies, including research on the SARS-CoV-2 virus in animal models, antiviral treatments, and vaccine development. NEDL does not currently perform what's known as gain-of-function work, according to its public disclosures. However, it maintains the infrastructure that would allow such research if federal policies permitted it. This capability keeps it under the microscope, not just for safety, but for ethics. Still, to its defenders, NEDL is a bulwark, a necessary bastion of scientific progress in a world that faces even more spillovers, climate-linked outbreaks, and antimicrobial resistance. In an age when new pathogens can circle the globe in hours, high-containment urban labs like NEDL may be less a luxury than a necessity. Number 12. Galveston National Laboratory, Galveston, Texas. Just a few blocks from the Gulf of Mexico, on a barrier island that's prone to hurricanes and rising seas, sits one of the United States' most advanced and high-risk biocontainment facilities, the Galveston National Laboratory, or GNL. Operated by the University of Texas Medical Branch and funded in part by the National Institute of Allergy and Infectious Diseases, the GNL is a Biosafety Level 4 lab designed to handle pathogens that could wipe out populations. It was completed in 2008. The lab was part of the U.S. government's post-9/11 effort to strengthen biodefense capability. It's one of only 2 operational BSL-4 labs in the country that's located on a university campus, the other being Boston's Needle, and it houses more than 80,000 square feet of containment zones, including multiple BSL-3 and 4 suites. But its location has been a source of concern. At the heart of its operations are Emergis infectious disease research. They study deadly viruses like Lassa fever, Crimean Congo hemorrhagic fever, Nipah, Ebola, Hendra, and various strains of highly pathogenic influenza. The lab does play a major role in testing countermeasures, vaccines, therapeutics, and diagnostics. But Galveston Island is exposed to hurricane threats, storm surges, and rising tides, and critics have asked, reasonably, why place one of the world's most sensitive biolabs in such a vulnerable location? Well, officials at the U.S. Department of Health and Human Services have defended the site, citing robust safety protocols, elevated construction, and redundant backup systems. Indeed, the facility is built to Category 5 hurricane standards. The BSL-4 suites are placed well above sea level, and its outer walls can withstand winds exceeding 200 miles an hour. The ventilation, water, and power systems are all protected by multiple redundancies, and during Hurricane Ike in 2008, the lab had not yet opened, but it was already put to the test, and it passed, sustaining no significant damage despite a 12-foot storm surge. Internally, the lab maintains strict access control. Only select federally cleared scientists are even allowed into the BSL-4 areas, which are sealed, pressurized work zones. And yet, as with all high-containment labs though, public trust is fragile. Some local activists have expressed concern about the lack of transparency in emergency planning. Others fear that future climate events could outpace even the most carefully engineered defenses. The 2021 Texas freeze, which knocked out power to much of the state, raised fresh alarms about the infrastructure resilience of the place. While still, supporters argue that placing the lab in Galveston, close to a major academic medical center and in a region with tropical disease risk, is strategic. In the balance between risk and readiness, GNL may be a necessary gamble. It's a lab that was built to face the future on the front line of humanity's battle against emerging biological threats. Number 11. The National Microbiology Laboratory in Winnipeg, Canada. In downtown Winnipeg, Manitoba, surrounded by office buildings, traffic, and a sprawling urban skyline, stands a medical lab that contains some of the most dangerous pathogens in the world. The National Microbiology Laboratory is Canada's highest security infectious disease research facility. It is a Biosafety Level 4 laboratory, and it's operated by the Public Health Agency of Canada. It was completed in 1999 and immediately established itself as a key player in global biosafety and virology. But its most controversial moments have come from what happens behind the secured doors and who's allowed inside them. The facility gained international attention in 2019 when 2 high-level researchers, Dr. Chu and her husband Keiding Cheng, both originally from China, were escorted out of the lab under mysterious circumstances. Dr. Chu had been involved with Ebola research and was known for her work in transferring virus samples to China. The Canadian government later revoked their security clearances, and in 2021 it was publicly revealed that they were under investigation for possible security breaches and unauthorized technology transfers to the Wuhan Institute of Virology. Though the Canadian government hasn't accused the researchers of espionage, the incident has left an enduring cloud over this lab, with parliamentary inquiries and calls for greater oversight of foreign collaboration in these BSL-4 facilities. But the NML is not defined by scandal alone. It's played a major role in global pandemic preparedness and outbreak response. During the West African Ebola outbreak in 2014, Canadian scientists from NML were among the first to deploy rapid diagnostic tools to the field. The lab also helped develop the ZMapp, or an experimental Ebola treatment, and it was instrumental in the early development of an Ebola vaccine, which has since been used to save thousands of people. It continues to act as a national reference center, processing pathogen samples from across the country and issuing real-time epidemiological reports. Internally, the NML is also home to Canada's Special Pathogens Program. That's a rapid response unit that's trained to deploy to domestic or international outbreak zones. These scientists not only work with highly dangerous pathogens in the lab, but they confront them in the field. While the Canadian government has assured the public that no dangerous pathogens were improperly released or compromised, some lawmakers have argued that NML should fall under more stringent federal oversight, including regular parliamentary review and public accountability for international partnerships. Number 10. The Service Research Center in France. Just outside the center of Lyon lies one of Europe's most secretive and critical high-containment labs, the Service Research Center. It is a military biomedical research center focused on infectious diseases, biological threats, and defense-related medical research. It is one of the few facilities in Western Europe authorized to work at Biosafety Level 4, and it's part of France's national infrastructure for biosecurity. The lab is managed by France's Military Medical Corps, the SSA, and it functions under the joint oversight of the Ministry of Defense and Ministry of Health. It was established in the 1980s, but it expanded and modernized significantly in the aftermath of the 9/11 terrorist attacks and the subsequent anthrax scares in the United States, which prompted European nations to ramp up their biodefense strategy. Unlike civilian labs, this one's not open to full public scrutiny. While it collaborates with various EU research programs, its dual-use nature means that a portion of its work remains classified. This includes testing and developing countermeasures for biological warfare agents, conducting pathogen modeling for military scenarios, and participating in NATO-aligned research for emerging threats. The staff here are trained not only in virology and molecular biology, but also in military-grade containment procedures, including field deployment protocols in case of biological incidents. These scientists are effectively soldier scientists capable of responding in war zones, conflict zones, or sites of suspected biological weapons. In 2020 and 2021, they were instrumental in testing COVID-19 vaccine candidates, particularly those with military applications for rapid deployment to troops or emergency personnel. They also contributed to real-time modeling of viral spread scenarios for use in national pandemic planning. All that said, the presence of a BSL-4 military research facility in an urban center continues to stir unease among bioethicists and watchdog groups. Calls have been made for greater public transparency, especially regarding gain-of-function work, dual-use technology exports, and international collaborations involving genetically modified viruses. France has so far resisted pressure to disclose full operational details, citing national security exemptions, but still it remains a partner to the WHO, the European CDC, and NATO's Joint Seaborne Defense Center of Excellence, which helps ensure that at least some oversight by peer agencies is going on. Number 9. Dugway Proving Ground in Utah. About 85 miles southwest of Salt Lake City in the desert of Utah lies a massive, heavily guarded military reservation known as the Dugway Proving Ground. At first glance, DPG might appear like many other weapons testing site, but Dugway is far more than that. It's one of the most secretive, high-risk biological research and testing facilities in the world. It's often referred to in the United States as Area 52. Its focus is chemical and biological defense. It was founded in 1942 and initially created during World War II as part of the U.S. military's rapidly expanding effort to test weapons in extreme environments. Over time, it became the primary continental testing site for biological and chemical agents. Well, today, while the U.S. officially denies any ongoing offensive bioweapons work, Dugway continues to operate high-containment labs. At the heart of the facility is the Life Sciences Division, which includes Biosafety BSL-3 containment laboratories. Now, these labs work with live pathogens to test the effectiveness of PPE, that's personal protective equipment, air filtration systems, and chemical neutralizers. Though Dugway doesn't house BSL-4 facilities, that's reserved for the highest level, its combination of indoor and outdoor testing protocols gives it a unique operational flexibility. But the site has not been without incident. In 2015, Dugway came under national scrutiny after the Pentagon revealed that the facility had accidentally shipped live anthrax spores to over 190 labs across the U.S. The spores were supposed to be killed using gamma irradiation before shipment, but failures in the deactivation process went undetected for years. The scandal prompted a months-long investigation by the Department of Defense, which concluded that biosafety lapses were systemic, not isolated. That revelation raised terrifying questions. How could a high-security lab distribute live anthrax without knowing it? And how many other pathogens could have slipped through similar cracks? Well, despite some efforts, concerns persist about the nature of Dugway's work. While the U.S. government has consistently stated that Dugway operates solely within the parameters of the Biological Weapons Convention, its location, size, and classification level leave it open to speculation. But security at Dugway is extreme. The installation is surrounded by fences, surveillance towers, motion sensors, and restricted airspace. Access requires federal clearance, and employees undergo background checks, polygraphs, and even biosafety certifications. The lab works closely with U.S. Amrid, that's the U.S. Army Medical Research Institute of Infectious Diseases, at Fort Detrick, which performs complementary lab-based studies at BSL-4 containment. Number 8. U.S. Amrid, Maryland. If there's one name that's synonymous with America's biological defense efforts, it is U.S. Amrid, the U.S. Army Medical Research Institute of Infectious Diseases, located at Fort Detrick in Frederick, Maryland. Since its founding in 1969, U.S. Amrid has served as the U.S. military's premier BSL-4 research institution, responsible for studying the world's deadliest pathogens. It's also one of the most high-risk medical labs on the planet, both in terms of what it contains and what has occurred behind its sealed doors. Originally built atop the remnants of America's biological weapons program that was officially terminated in 1969, U.S. Amrid transitioned into a facility focused on biodefense and preparedness. Their research spanned a huge range of pathogens: Ebola, Marburg, Lassa fever, hantavirus, and other high-consequence viral agents. But the facility is part of the broader U.S. biodefense complex, and it works closely with the Centers for Disease Control and Prevention, the Department of Homeland Security, and the World Health Organization. But U.S. Amrid's track record is not without a few blemishes. In 2001, the facility became the unexpected epicenter of a national crisis when it revealed that the anthrax spores used in the deadly Mail attacks, which killed 5 people and sickened 17, had likely originated from within its own spore stocks. FBI investigators eventually traced the anthrax strain to a flask stored in U.S. Amrid's BSL-3 lab. The main suspect, Army scientist Bruce Ivins, died by suicide in 2008 before he could be brought to trial. Then in 2019, U.S. Amrid was shut down temporarily by the CDC due to biosafety protocol violations. Reports indicated that wastewater decontamination systems had failed, compromising the containment chain required for working with BSL-4 pathogens. Following the shutdown, the lab underwent extensive renovations. It was reopened under tight federal oversight in 2020 and resumed its core operations, including crucial COVID-19 research on vaccine development. However, the 2019 shutdown highlighted the fragility of even the most advanced biosafety protocols. U.S. Amrid operates one of the most advanced suites in the country. Researchers have to wear fully encapsulated positive pressure suits, and every material that enters or exits the suite goes through chemical sterilization and/or incineration. Its stated mission is to support warfighter readiness, ensuring that troops can be deployed safely even into biologically hazardous environments. Critics continue to push for greater transparency, especially given the dual-use capability and past security failures. Still though, U.S. Amrid remains an essential node in the U.S. and global biosecurity infrastructure. Moving on to number 7, the Center for International Research, Central Africa. In the tropical rainforests of Gabon, a relatively small Central African country along the equator, lies one of the most important yet least known high-risk biological research centers. The Center for International Research may not make global headlines like labs in Wuhan, Boston, or even Fort Detrick, but let's make no mistake, it is one of the few facilities on Earth that's authorized to study live Ebola, Marburg, and Lassa viruses in full BSL-4 containment. Founded in 1979, it was originally established with French government support. Its primary mission was to study tropical diseases affecting local populations, particularly zoonotic viruses that's transmitted from wildlife to humans. Central Africa is a hotspot for filoviruses. That's a family that includes Ebola and Marburg, and repeated outbreaks in nearby Democratic Republic of Congo, the Republic of Congo, and Uganda have made the region a prime candidate for real-time virus tracking and field response. Unlike many Western BSL-4 facilities which operate far from the front lines, this one's embedded in the very ecological cradle where these viruses emerge. This proximity gives it a scientific edge and an enormous biosafety burden. Field samples from bats, primates, and forest rodents are transported to their labs for isolation and genetic analysis. It also houses an on-site primate research colony that's a controversial but crucial resource for understanding cross-species transmission. Gabonese and French scientists work together on both field work and lab-based research, often in partnership with the World Health Organization and the US CDC, especially during active outbreak seasons. It also continues to serve as a sentinel station for new viral threats, contributing to genomic data to international pathogen surveillance systems like GISAID and NextStrain. Yet the risks here are pretty substantial. The lab operates within an infrastructurally limited country where power outages, road blockages, and supply shortages are not uncommon. Even the most advanced containment protocols can be vulnerable when operating in a setting with periodic blackouts and political instability. In 2018, a temporary shutdown due to a regional unrest sparked some concern within the international scientific community about the security here. The lab was eventually stabilized and it resumed operations, but the incident underscored that fragile equilibrium between cutting-edge science and volatile geography. Critics have also questioned the ethics of conducting such high-risk research in a developing country, arguing that France and international donors gain disproportionate scientific capital, while Gabon assumes the majority of the ecological and biosafety risks. The leadership there has countered that the lab offers local training, public health infrastructure, and research capacity that benefit both Gabon and the broader African region. Number 6. The Institute of Virology, Berlin, Germany. In Germany's capital, Berlin, within one of Europe's oldest and most prestigious hospitals, sits a high-containment virology lab that's become one of the most influential centers for pandemic science. While not as secretive or as fortified as Dugway or Fort Detrick, this lab operates BSL-3 Plus and BSL-4 facilities, and it played a pivotal role in identifying, sequencing, and globally disseminating information on the SARS-CoV-2. The institute is best known internationally through the work of Dr. Christian Drosten, a virologist who helped develop the world's first diagnostic PCR test for COVID-19 in early January 2020, weeks before the virus had even reached Germany. The team shared their methodology openly with the WHO platform, allowing countries across the world to begin testing before local outbreaks. But their involvement in high-risk virology began long before COVID-19. Unlike more militarized facilities, the labs here exist within a functioning urban hospital campus. Patients are being treated just floors away from the research zones, and while strict barriers separate BSL 2, 3, and 4 labs from the clinical areas, the proximity has raised eyebrows in biosafety circles. Their influence also makes it a target for international cyber espionage. In 2020, German authorities confirmed that state-backed hacking groups attempted to penetrate their data networks during COVID-19's first wave, presumably seeking early-stage vaccine data and mutation logs. These attempts were thwarted, but they reveal the geopolitical importance of pathogen data in a world increasingly shaped by biological risk. And critically, they don't just conduct lab work, it sets global public health policy. The scientists here advise the German Bundestag, the European Union, and the WHO task force, meaning that the research conducted here has policy ramifications at the highest levels. That influence makes containment, accuracy, and transparency all the more critical, and the consequences of any breach, even theoretical, all the more profound. Number 5. The Bundesphere Institute of Microbiology, Munich. In the city of Munich, better known for beer halls and Baroque architecture than high-stakes biodefense, sits one of the most secretive, regulated military medical laboratories in Europe. The Bundesphere Institute of Microbiology, operated by the German Armed Forces, or the Bundeswehr. Founded in 1959, this institute was established during the Cold War as a military medical unit to defend against biological warfare and infectious disease. Over time, its role expanded to include research on emerging pathogens, vaccine development, and diagnostics. On one hand, it's a legitimate research facility that publishes in peer-reviewed journals, collaborates with the Robert Koch Institute, and provides support for WHO-led outbreak response. On the other hand, it operates as a classified military installation with tight internal controls, limited public information, and research mandates that include pathogen security and battlefield exposure studies. In 2018, the Bundesphere Institute was involved in analyzing mysterious packages sent to embassies in Berlin, assessing whether they contained any biological agents. In 2020, during the COVID-19 pandemic, the lab conducted high-throughput PCR testing for military and government officials. And despite its service record, the lab is not immune to any scrutiny. German civil liberties groups have raised concerns about its lack of transparency, especially regarding dual-use research. That's the kind that can be used for both peaceful and military ends. Another point of tension is its training of international military personnel. While this supports global biosafety cooperation, critics do argue that it risks the proliferation of sensitive techniques and protocols that could be abused in countries with less stringent regulatory frameworks. But the Bundesphere Institute does play a major role in Germany's pandemic wargaming and national emergency drills. They simulate scenarios like smallpox release in public areas or even deliberate contamination of the food chain. Its role is to provide microbial forensics, strain typing, and coordination with NATO's seaborne defense infrastructure. Number 4. The Center for Infectious Disease Research in Shenzhen, China. In one of China's most technologically advanced cities, Shenzhen, in the Guangdong province, is a facility that few outside the scientific communities had even heard of before 2020. The Center for Infectious Disease Research is housed within the Shenzhen's Third People's Hospital, and it quickly became one of the most watched medical labs in the world when it emerged as one of the first to isolate and sequence the SARS-CoV-2 virus at the earliest stage of the global pandemic. But its rise to prominence has also placed it under some scrutiny. With strong ties to China's national biosafety initiatives and one of the most aggressive coronavirus research programs in Asia, this lab walks the line between cutting-edge innovation and global unease about transparency. Its early detection work, while medically vital, it also drew some unwanted attention. As Chinese government policy shifted in early 2020 to restrict independent public communication about the virus, several Shenzhen researchers were silenced, and others were required to obtain government clearance before publishing new findings. These events raised concerns about scientific censorship, especially regarding the origins and early transmission patterns of COVID-19. In 2021, leaked documents revealed that the Shenzhen lab had filed patents for novel viral vector delivery systems, raising eyebrows about potential genetic manipulation. While these technologies have clear therapeutic applications like vaccine development, they also fall under dual-use categories outlined by the Biological Weapons Convention. The political environment in which the lab operates makes open scientific exchange difficult. International experts have repeatedly called for greater access to raw data from the lab's earliest COVID-19 cases, and those requests have gone unanswered. Despite the controversy, though, this center continues to play a role in pandemic response. Its high-throughput PCR testing labs process tens of thousands of samples daily, and it's launched rapid program sequencing platforms to track COVID variants in real time. Plus, it serves as a training ground for China's next generation of virologists and epidemiologists. Number 3. The Pasteur Institute, Paris, France. Just blocks away from the Eiffel Tower and surrounded by cafes, apartments, and schools lies a facility where the world's most dangerous pathogens are studied, sequenced, and sometimes synthesized. This is the Institut Pasteur, a storied name in the history of science, and also one of the most influential and high-risk biological research labs operating. It was founded in 1887 by legendary microbiologist Louis Pasteur. The institute is globally respected for its work on vaccines, immunology, and virology. It was here that the rabies vaccine was developed, where early work on HIV identification took place, and where numerous Nobel laureates have conducted world-changing research. Their BSL-4 facility is located in Lyon, away from the public-facing headquarters in Paris, but its operations are centralized and governed by Pasteur's central administration. But what elevates Pasteur's risk profile beyond the pathogens is the dual identity of the place, a world-class civilian institute with extensive military linkages. The French government has for decades used Pasteur as a cornerstone of its biosecurity infrastructure, drawing upon its expertise of pandemic or bioterrorism events. The lab is also deeply involved in international gain-of-function debates. In 2011 to 2012, a Pasteur virologist, Dr. Foucher, in collaboration with Dutch and U.S. counterparts, helped create a mutated H5N1 influenza virus that could be airborne transmitted between mammals, a development that horrified bioethicists and thrilled biodefense strategists. But Pasteur's openness to collaboration has led to a global footprint. Their network includes labs in Cambodia, Vietnam, Guinea, Senegal, and Iran, creating an international constellation of BSL-2 and 3 partner sites. While this global reach does enhance their capacity, it also increases the risk of security lapses, unauthorized transfers, or even exploitation by bad actors. Despite its prestigious status, Pasteur has not escaped laboratory errors. In 2014, the institute admitted to the loss of over 2,000 vials containing SARS-CoV, the original SARS virus from 2003. An internal investigation revealed that the samples had likely been accidentally destroyed or misplaced, but not before the incident sparked fears about inventory mismanagement and regulatory blind spots. The Institute's scientists do sit on pandemic policy boards, write global vaccine protocols, and influence the funding decisions at the European Commission and the Bill and Melinda Gates Foundation. If information, personnel, or samples from Pasteur were compromised, the fallout could be devastating as an actual lab escape. Number 2. The Defense Science and Technology Laboratory in the United Kingdom. Hidden behind layers of barbed wire and decades of secrecy in the English countryside is one of the most enigmatic biological research facilities, the Defense Science and Technology Laboratory at Porton Down, Wiltshire. It's operated by the UK Ministry of Defence. This site is a juggernaut of biodefense and chemical and biological warfare countermeasure development, and it's often whispered about in the same breath as Fort Detrick or Dugway. Established in 1916 during World War I, Porton Down began as a response to Germany's use of poison gas on the battlefield. While the UK officially abandoned its offensive biological weapons program in the 1950s and signed the Biological Weapons Convention in 1972, Porton Down's labs remain active, transitioning into defense research and testing against a hypothetical bioweapons attack. Today, Porton Down is the home to the UK's only BSL-4 containment lab, where scientists study Ebola, Marburg, Lassa, and genetically engineered threats. It's also the national hub for chemical, biological, radiological, and nuclear defense, CBRN, handling everything from battlefield vaccine development to incident response. But the facility has also been the subject of some intense criticism and a bit of controversy. From the 1940s through to the 1980s, Porton Down conducted human testing on thousands of UK military volunteers, some of whom were unknowingly exposed to chemical agents, including sarin, VX, and mustard gas. Many of these veterans later reported chronic health issues, and lawsuits have periodically emerged alleging ethical misconduct. Though in 2020, Porton Down played a pivotal role in the UK's COVID-19 response, especially in evaluating antiviral drugs and validating new test kits. Despite its contributions, though, the facility's culture of secrecy continues to stir public unease. While certain parts of their work are made public through government press releases or parliamentary oversight, many of its own programs remain classified. Because of its strategic role, Porton Down is considered a prime target for espionage, and it's reportedly faced cyber attacks from both nation-states and independent hacker groups seeking access to synthetic biology data, chemical weapon forensics, and bioterrorism countermeasures. Number 1. The Biological Research Institute of Israel. Just south of Tel Aviv, in Israel, lies one of the world's most mysterious research facilities, the Israel Institute for Biological Research, or IIBR. Officially, its purpose is to support national health, pharmacology, and biodefense. Unofficially, it's rumored to be the epicenter of Israel's biological weapons program and one of the most closely guarded high-containment labs in existence. Founded in 1952, shortly after Israel's establishment as a nation-state, it was reportedly built with assistance from scientists from post-war Europe, some of whom had worked in advanced biochemistry and virology labs in the UK and Germany. Despite being the subject of global speculation for decades, it rarely releases any internal data, doesn't participate in open access science initiatives, and doesn't allow foreign inspection. As such, it's earned a reputation for being one of the most opaque and highest risk medical labs in the world. Over the years, various incidents have added fuel to the fire. In 1992, a plane carrying 3 IIBR scientists to Moscow crashed in Amsterdam. While officially a commercial flight, reports surfaced that they were transporting dangerous cargo, possibly for a joint project. The Israeli government refused to comment. In 1997, Mossad agents attempting to assassinate Hamas leader Khaled Massal in Jordan reportedly used a mysterious, fast-acting neurotoxin. Jordanian doctors were only able to save him after Israeli officials, under intense diplomatic pressure, provided the antidote. During the COVID-19 pandemic, the IIBR took on an uncharacteristically public role. It developed one of Israel's earliest vaccine candidates and worked on monoclonal antibody therapies. While much of this was publicized, including clinical trials, scientists around the world noted that the institute's data releases were minimal compared to international norms. There are also some persistent rumors, never confirmed, that IIBR has developed ethno-specific biological agents, i.e. viruses or toxins that target specific genetic markers more prevalent in certain populations. These claims, largely driven by adversarial intelligence reports, remain unproven, but they do underscore the deep paranoia and high-stakes environment surrounding the lab's work. Despite, or because of its secrecy, the IIBR is often at the center of international intrigue. Its researchers, while mostly anonymous to the public, occasionally appear in scientific conferences under pseudonyms or broad institutional affiliations. According to some leaked documents, the lab also participates in regional epidemic monitoring through front organizations tied to humanitarian or research NGOs. The IIBR's very existence does challenge the paradigm of open science. It represents the ultimate high-risk model, a national facility isolated from the scientific commons, conducting research that could save millions, or in the wrong hands or under the wrong orders, devastate entire populations.